Hey there, hopefully with your triads you were able to discover that both Sasha and Derek's method for least common multiple was they also were both right. So I wanted to take some time to show you how you can also use the prime factorization and factor trees to help you find the least common multiple. I know that most of you are comfortable with taking two numbers. So let's take two numbers. Let's do 36 and 48 again. And most of us, to find the least common multiple, we start by listing out the multiples, especially if we have a calculator handy. It's wonderful. So I know I can do 36, 72, then I need my calculator, 108, and then plus 36 would be 144. Let's start with 48. 48 times 2 is, so we have 48. We have 96, and then 144. Thankfully, I can stop now because I see that my least common multiple is 144. Now, as the numbers get bigger and as they get nastier, listing out these multiples can be dangerous because it can be time-consuming, and you're more susceptible to make a mistake if you do not have a calculator accessible to you. So why don't we look at, was it Sasha who used factorization? Why don't we look and see how you can use the prime factorization to arrive at the same answers that we just got right here for least common multiple. So let's say we had to find the least common multiple using the prime factorization. The really good news about that is we already did this to find the greatest common factor. So instead of wasting our time in remaking a factor tree, we're actually just going to look at the factor trees and the prime factorizations that we've already made. Here are our prime factorizations. For least common multiple, it's a little bit different than greatest common factor, because what you're doing here to find the least common multiple is you're still looking to see what factors they have in common. So I noticed that they each have 2's, right? But instead of taking the least amount of 2's for the least common multiple, you're going to want to take the most. So 48 has 4 2's. We're going to use all of those for our least common multiple. Then I see that 36 has 2 3's and 48 has 1. We're going to steal both of them for least common multiple. Now we multiply them together, the fun part. 2 times 2 is 4, 2 times 2 is 4, 3 times 3 is 9. I think I accidentally left some things up, so let's erase those guys. From there, we're going to do 4 times 4 is 16 times 9. And if I look at 16 times 9, 454. The least common multiple is right there, which is awesome. There's another example I wanted to show you with the least common multiple, because even when one of the prime factorizations for least common multiple, they do not need to match for you to actually use them in your final least common multiple search. And let me just show you the example. You might want to write this down with me to stay focused and on track. Why don't we take 24 and 60, which was in the example. 24 and 60. So here you are going to want to break down, we're doing our factor trees. I personally am going to do 2 and 12 because that's the first thing I saw. I know 2's prime. 6 and 2. You could also do 3 and 4, but it's however your brain works. It's how mine does. 2 and 3. So our prime factorization for 24 is 2 times 2 times 2 times 3. If you wanted to get real fancy like we did on Friday, you could write 2 to the power of 3, or 2 cubed times 3. So then for 60, what we're going to do is break it down. I personally, my brain works in powers of 10, so I'm going to do 6 times 10. Both of those are composite, so I can break down to 10 into a factor pair of 2 and 5, both prime. And 6, I can do 2 and 3. Now, let's write the prime factorization of that one. I have 2 times 2 times 3 times 5. Now to find the least common multiple between these two numbers, I'm going to just simply look at the prime factorizations of each one. Now, for the least common multiple, you are going to want to take what they have in common. But so if I look, I see 3 2's here and 2 2's here. You want to take all 3 2's. Now, For the least common multiple, we're also going to look at the factors. Another factor they have in common here is 3, so we're just going to steal one of the 3's. The one thing that makes least common multiple different than greatest common factor is with greatest common factor, you're taking what they share, right? What they have in common. For least common multiple, you actually can include the numbers. You need to include the numbers that at least even just one of the numbers has. So our original number has, so 60 has 5. You have to include that prime factor to end up at the least common multiple, even though there's no 5 over here. So let's see what happens when we multiply these together. 2 times 2 is 4. 2 times 3 is 6. And then I have 5. You can multiply in any way that is easy for you. So I personally know this is going to end me with a 0 in the ones place, which makes my life easy. And so 4 times 30 is 120, and that's going to be my least common multiple. Personally, when I see this method, I'm like, oh my goodness, to me, this is so much easier than having to sit here and take 60 and 24 and just list everything out, especially if I do not have a calculator available to me. So I really think that using the prime factorization and factor pairs is also a wonderful way to find the least common multiple. One thing to keep in mind about this is if it asks you to find the greatest common factor and the least common multiple of a number, you only have to make your factor trees once, and then you just have to do something a little bit different with your prime factorization at the bottom for the greatest common factor and the least common multiple. So essentially, you can work out 2 problems for the price of 1 just by using prime factorization. Now it's your turn to practice. Feel free to rewatch this video again. I will send it home on Dojo tonight for anybody that would like to utilize it for their homework. But this is an awesome strategy that you are going to want to utilize. Enjoy the rest of your time in math today. Bye.